Bill Foy, who is the chair of the SOAFEE SIG governing body, to basically do a welcome and an intro to SOAFEE. Okay,
Great.
Bill, I give you the
Thanks, Robert.
remote control.
And as soon as I see that, I'll take it. Welcome, everyone. And this is day one, as Robert mentioned, and looking forward to some really great presentations and discussions and Q&A as well. Let's see.
You should be able to go up or down and control the slides.
Okay. Here. Yes, there we go. So we're going to start off with a quick vote here. I've gone up, Robert, so I don't know. Or wait a second here. I'll do it again. We have a quick poll that we're going to take today.
So Gina will send the poll.
Yeah, and will that appear in the chat, or where
it will appear on the screen? So Gina, if you'd like to do the poll, there you go.
There we go.
Participation. So I think we'll close the poll in about 5 seconds. Okay, Gina, can you share the results?
All right, very interesting that 54% are using already, and 30% not using today but planning, and only 16% no. That's very encouraging. Yeah, that's excellent. So we have 2 days for this event, and I'm moving a little bit fast here. Day one. So day one today, we'll go through an agenda later, but this is SOAFEE SIG updates. So from the steering committees, working groups, blueprints, integration, and other initiatives. And then as Robert mentioned, we will have time at the end for Q&A. So please submit your questions throughout the day. And then day two also is very interesting with member presentations. So the real world applications and technology integrations with SOAFEE, which I think many of you will find very interesting. So I think many of you know SOAFEE, but just by way of introduction, so scalable open architecture for embedded edge. So this industry initiative is to extend cloud native software experience to automotive workloads through this SIG. And I think the second box, which is really important, is around software architecture, which is enabling for the first time automotive functional safety and real-time requirements. This is what I think is really interesting and really important. And then, of course, an open reference software implementation. So enabling prototypes and early development starting now. And you'll hear more about that later. And then as we look at like, why are we doing this? What's really the importance to the industry? And we've labeled it shift left, and this has become a big term in the industry now for automotive development. But when you can begin to separate hardware and the application software development, you can see that vehicle development can be done much more quicker. When you can begin to do application development and deployment from the cloud. And then besides the speed, obviously on the bottom graph on the right-hand side, being able to do lifecycle OTA updates and feature upgrades is really the gold mine for companies. And when we look at SOAFEE and the architecture vision, basically what I want you to focus to is where you see the SOAFEE in the vehicle. So mixed critical orchestrator, container runtime, and the hypervisor OS. And then you see something very similar in the cloud. This is what allows environmental parity, allowing us to use the same ARM architecture in the vehicle as well as in the cloud, and much more from what you'll hear today as well. And when we can do the CI/CD, in the cloud for the infotainment apps, the ADAS apps, that is what we're after. In this overall working group and team. So we have set up the overall SOAFEE SIG. So this is the working structure. And we have the basically the technical steering committee that's run by Matt Spencer that you'll hear from later. So for Matt, he has 4 different areas that you can see here. So you'll hear from Martin Stam from Continental later on system architecture, from Neil on cloud native development, and then Luke is leading the cloud native tooling. And then the reference implementation, you'll see MR is running that. And then, of course, the community manager is important. Estella is doing a great job for the project planning and tracking. And then you'll hear from Robert next around the marketing and go-to-market areas for what we're doing. And you'll hear quite a bit about all the companies that are joining. And my target is that for each company that joins, it's just not a matter of being present as like part of the discussions, but it's really about how do we join one of these working groups and really get involved. So just real quick for agenda, from 6:15 a.m. Pacific time, or in about 4 minutes, we'll have Robert come up and talk about the first year with SOAFEE and give some of the highlights, as well as where we're at with all the members. And then Matt will talk about the SOAFEE architecture, technical structure, followed by Martin. As I mentioned, we'll do the system architecture. Neil and Conrad will give a cloud native dev working group update. Leonardo will do a cloud native tooling working group update, followed by Amar, who will do the reference implementation. We'll have a short break, and then 10 minutes later, we'll talk about something I think is really important around the SOAFEE Blueprint integration labs and roadmap. And then Daniel will talk about the working with others initiatives, so how we're thinking about other industry groups. And then Robert will come back, talk about getting involved, and then we'll have time for Q&A for about 20 minutes. So again, please submit your Q&A throughout the presentations, and then we'll make sure that we're picking up the themes and being able to answer specific questions and themes at the end. So again, I think we have 2 exciting days and really appreciate everyone for being here. And let me turn it over to Robert to talk about the first year with SOAFEE.
Thank you. Thank you, Bill. It's certainly been a very interesting first year of SOAFEE. And as you can see, we even have a birthday candle or anniversary candle, depending whether we think it's a birth or an anniversary. So I'm just going to take a little bit of time letting you know kind of what we've been up to. A lot of what we're focusing on today is really what's coming next. And I think it's really important that we kind of look at now the execution phase of SOAFEE. And so that's what we're going to talk a lot about from the different working groups. And then tomorrow is going to be really interesting, because this is some of our member companies will be talking about how they're involved with SOAFEE, how some of their expertise and their technologies and their implementations are coming alive with SOAFEE. And that's really key, because that's the road to sort of deployment using the SOAFEE architecture. So let's have a look. So SOAFEE was launched September 2021, so just over a year ago. Got a lot of coverage in both, well, around the world. So it was kind of hit a really interesting kind of like subject matter as people were looking at the sort of next generation of vehicles. The fact that there was going to be a lot of software content, the fact that these vehicles had to be updated, as Bill showed with the shift left, it really, people were looking for how are we going to do this? And so it got quite a lot of coverage from the press and the analysts. Quite shortly after, we had our first demonstrations of SOAFEE. So we had a virtual event called the ARM Dev Summit in October, and we actually had a workshop showing how you could bring a workload from an AWS cloud instant down to an edge platform. And I think this is still available for you to watch. There's actually an updated version from I think the last Dev Summit from 2022. And then we actually did the first physical demo, as you can see there in the picture on the right, at AWS reInvent last November. So even though SOAFEE had only been launched 2 months earlier, because we had actually released the first version of the reference implementation, which we'll talk about in a little bit, it meant that we could actually start showing SOAFEE off, which was great. So in October, we also formed the governing body. And this was important because we really wanted to go across the industry. We wanted to have, potential consumers of SOAFEE, OEMs and tier ones. We wanted to have experts in cloud. We wanted to have experts in software development. And so we formed the governing body with Cariad and Woven Planet from the OEM side, Bosch and Continental from the tier one, AWS, you just heard from Bill from the cloud side of things, and then Red Hat and SUSE from the software development and looking at things like orchestration. So it was very key that we had input from a lot of both consumers and contributors to the SOAFEE architecture. So shortly after that, we started forming the working groups and bringing working group members on. And certainly through this year, through 2022, we've had real active participation from all across the industry. And you can see this is actually the latest set of announced members. This actually is on the SOAFEE website. So if you go to soafee.io, you can see new members and also the membership of both the governing body and the working group. But you can see we've got a lot of, different types of expertise. We've got our silicon partners. We've got RTOS. We've got people that understand safety, understand security, application workload people. I mean, it's across the board, and it's really, really helping us form what the SOAFEE architecture needs to look like, but also then testing out that architecture with both reference implementations and commercial implementations. And that's really key for going forward in this second year of SOAFEE, to be able to actually bring all of these expertise, some technologies into the SOAFEE Special Interest Group. So one of the key parts to SOAFEE is having a reference stack. And as Bill showed, SOAFEE is really an architecture first, but if you don't have a reference implementation, it's really difficult for people to get their hands around or get to grips with the architecture. And so what we did early on, and this was available pretty much straight after we launched SOAFEE, is we had the first version of the SOAFEE open source reference stack. And based around Linux, having containers, even having a reference workload with the AutoWare.auto. And this enabled people to start working with SOAFEE, enabled people to put demonstrations together, POCs, but more importantly, as working group members come on into the SOAFEE SIG, they can quickly get going with this reference implementation. So they'll understand what the architecture looks like and understand really how their technologies and their expertise can fit into this. We're just about to launch release the second version of the SOAFEE reference stack. This will actually bring virtualization in. So, a lot of the tenant you'll hear today around SOAFEE is about things like containerization, orchestration. But within the automotive world, it's actually important to be able to have things like freedom from interference. And that's where virtualization will bring that in. So that was really kind of the first thing we wanted to actually bring into SOAFEE. We've also been working on the AutoWare workload, and you'll hear from Daniel Bernal a little bit later on about something called a blueprint, which is actually taking an application and showing how it works with SOAFEE. So not only are we releasing a reference implementation, we're actually giving workloads that people can start going with the sort of things that they need to do. In this particular case, it's an autonomous workload. So you can really see how these workloads are brought into containers, orchestrated, all that sort of stuff that's kind of key to SOAFEE, and really making this available to the external consumers and potential contributors to SOAFEE. We have a roadmap that we're going to show a little bit later on, but there's a lot of things that we want to put into SOAFEE sort of going into the next half of 2023. And so bringing things like the safety side of things into the SOAFEE architecture. So that's really kind of looking at the reference stack. You'll actually see a presentation a bit later from Anmar, who's the chair of the reference implementation work group. So another thing that's going to be important is having SOAFEE available on different architectures. And another key part of SOAFEE is its ability to easily move across different hardware platforms, which makes it easy to develop on one particular platform, potentially to deploy on another platform. So you can start your development early, as in Bill's shift left diagram, without necessarily having to have your deployable hardware there. And so we actually have a platform called the AVA Developer Platform, which is a 32-core Ampere processor, lots of expansion PCIe slots, so you can plug in different accelerators or GPUs and really start testing your workloads, before you're actually got anywhere close to your deployable platform. We also then have our SOAFEE partner platforms. So you can see a couple of them up front, Continental with their CAD platform, and also Marvell with their CRBs. And as we bring new silicon partners into SOAFEE, they will be bringing their reference platforms, having SOAFEE ported onto it. And as Daniel will talk about, we're also doing integration labs, which will actually make those hardware platforms sort of more accessible to the outside world. Another interesting part is also having the ability to get going sort of easily. And so using things like some of the maker platforms like Raspberry Pis, Turing Pis, they're going to be important as well, so that we can actually get developers working, quickly and easily from day one. So where are we going? So we have this vision. We've called it Project Eagle. It was originally called Project Moonshot, but we figured that moonshots don't always succeed. So we decided to call it Project Eagle. Eagle was the first lunar lander that landed on the moon. So it's the first successful moonshot. And what this is really trying to do is to show what we're trying to do with SOAFEE and how we're going to achieve it. And you're going to hear more detail about each of these topics as we go through today. But really, we're having these different application-specific blueprints. You can see in the middle there. They're going to be developed and deployed from the cloud. They're also going to come into these integration labs and different hardware platforms. So this is really the ability for us to use SOAFEE and give you example workloads to run on example hardware platforms. So this is really a very tangible thing that we are going to be providing in this second year of SOAFEE. And that's really what this is all about, is what are we going to do? Year two is execution. We did a lot of bringing things together in year one. We got our working groups and our governing bodies and our first reference implementations out. Now this is really real kind of acceleration. And so we're going to bring in both the architecture and the reference implementations are going to advance as we go through this year. We're actually using use cases from our member companies to help test out the SOAFEE reference implementation and also prove out the SOAFEE architecture. We're setting up these integration labs and blueprints, which will basically have open source and commercial workloads as necessary. We're going to be bringing SOAFEE to new hardware platforms, just talked about that. We're also, and you'll see this from the roadmap a little bit later on, we're actually going to be bringing software commercial solutions into the SOAFEE architecture. That's super important for the deployment of a SOAFEE-based system, because you need to have either the safety criticality or commercially deployable parts to these that fit into the SOAFEE architecture to actually make this work. But we're also going to be continuing to create the demos and proof of concepts and offer workshops so people can kind of get hands-on with SOAFEE early. Another thing that Daniel Krippner is going to talk about a little bit later on is it's become very clear that the world that we live in with automotive, software development, software-defined vehicles, all that sort of stuff, it's really important that we collaborate. And we've always seen SOAFEE as being a collaborative special interest group, bringing people from across both the automotive, but also the software development world. We now need to do the same with other initiatives and figure out how they fit into SOAFEE, how we fit within them. Are they a consumer? Are they a contributor? Are they both? And we're going to talk a little bit more about what we've done in the first year. And again, this is something that we're going to be doing more of in the second year. And then obviously at the end is to get more people involved with SOAFEE, having more voices in SOAFEE, more expertise in SOAFEE, and then having potentially more consumers of SOAFEE as we go forward. So with that, we are going to do our second poll. So Gina, do you want to queue up poll 2? Okay, this one's all about SDV. So it's interesting because a lot of people talk about SDV. It'd be really interesting to get your views as attendees as how important software-defined functions and a software-defined vehicle is to you. Then we'll know if we're doing the right thing. It was interesting with poll 1 that obviously you're interested in utilizing the cloud. The question now is, is this for software-defined vehicles and software-defined functions? Okay, we're up to 67%, probably another 10 seconds or so. Okay. All right, I think we're close to closing the poll. Okay, Gina, if you'd like to share the results. Well, look at that. Not a single one of you says software-defined vehicle is not important. Okay. And the fact that it's very important to 85% of you. So this is interesting, and this is key. And a lot of what we're going to talk about, in the next 2 days is really looking at, how you can develop and deploy your software-defined functions. Okay, with that, I'd like to now hand over to Matt Spencer. Matt, if you can turn your camera on and your mic on. There you go. And what I'm going to do is I'm going to give you control, Matt, so that you can control the slides.
Okay.
Okay, so you should be able to go up and down on the slides, Matt.
Let's see if this works. Oh no, I went the wrong way.
It works.
Okay.
All right.
All right. So a quick introduction to me. My name is Matt Spencer. I'm a technical director in Arm's automotive business line. I've been involved with SOAFEE for I can't press anything now. For over 3 years now. So we've been working on SOAFEE for a long time. SOAFEE started as a conversation with tier ones and OEMs at a conference where we were looking at the complexity of software-defined vehicle. I'm now one of the primary architects behind SOAFEE, and I'm also chair of the technical steering committee. And what I want to do is give you a high-level overview of what the technical steering committee is doing, and then we'll hand over to the working group leads to give you more in-depth details of what they are actually working on. Okay, so the first thing to talk about is the SOAFEE architecture, and Robert mentioned having a roadmap for the SOAFEE architecture, but I think it's important to express what the SOAFEE architecture is at the moment. So we have 2 primary documents that are being worked on at the moment, and the SOAFEE architecture specification V1.0 is an expression of the current state of the art. It's what we have today in the reference implementation of SOAFEE. And it's basically an expression of the standards that we use to implement the SOAFEE architecture, and how we can use those standards to help alleviate some of the complexity, the deployment and development complexity of our software-defined architecture future. The reference implementation EWOL is freely available, and there are, if you go to gitlab.com/SOAFEE, all of our assets are being made available through that one portal. So we have EWOL there, and we have another project called Meta EWOL Machine that gives you the ability to build for the EWOL for specific SOCs. SOAFEE at its heart is, as I say, an expression of open standards. So initially, we are bringing into scope OCI and CNCF, and that gives us specifications around the container runtime specifications, the container image specifications, the registry specifications, and CNCF gives us additional features around the orchestrator. So the Kubernetes APIs themselves, plus the tooling that goes along with Kubernetes to enable it to do things like device discovery and the like. And at the core, SOAFEE wants to extend these specifications to make them relevant in the automotive domain. So how do we build things like real-time containers? How do we build a container environment that's functional on Cortex-R, so real-time processors, as well as Cortex-Ms, which would be our microcontrollers, things that are traditionally highly resource constrained and you know, they don't have the memory of our application cores or the compute capability of our application cores, but they form a very valid function in the end vehicle. The importance of that document is that it means that the commercial software vendors around SOAFEE can create an equivalent implementation of the reference architecture. So again, Robert mentioned blueprints, and we'll go into more detail about those later. So we take the OpenAD blueprint that brings an autonomous drive solution in a containerized microservices way to EWAL, the reference implementation of SOAFEE. That same workload will be deployable to one of our commercial software vendors. So it starts to show you how you can create a go-to-market solution. You can go from research and development into deployment without having to throw away any of your code, the important part of your software stack, which is the things that interact with the people in the vehicle, the things that make the software-defined vehicle work. Now, I think we're going to be sharing these documents offline, so there's a link at the bottom of that page to the architecture specification. But the second part that's really important from a SOAFEE perspective is the architecture vision document. And that describes, and again, this is a work in progress, we're still putting the finishing touches to that document, but it describes the architectural vision, the end point for where we want to get to with SOAFEE. And it's an expression of the gaps, the things that aren't currently available within the standard OCI domain, because OCI and CNCF were defined for the infrastructure world, and they have no need at present to have an understanding of functional safety, of real time, and necessarily of things like para-virtualization for accelerators to get workload portability, all sorts of things that are of interest to us in the automotive domain. So those are the architecture documents. They're open and freely available. Anyone can read and comment on those. So please, if you are that way inclined, please have a look at what we've created there, and please feel free to make comments and help us evolve the architectural vision if you have specific ideas you want to bring into scope. Right. The second thing I wanted to talk about, and again, there's the top right, we have a link to the document that describes the use case process. SOAFEE is working in a potentially very complex domain, and it becomes difficult to understand how we prioritize what needs to be done, or even how we define what needs to be done. So we have created and are trialing a use case process whereby industry leaders, the tier ones, the OEMs, the people in the day-to-day life of the autonomous and software-defined vehicle are feeling the pain points of that transition towards software-defined. So they define a use case that expresses exactly what the problem is, what they're trying to achieve. And then SOAFEE will take that use case and analyze it from a number of different perspectives. So what I've tried to show here, and I'm not very good at drawing pictures, so you have to, as much as Robert would like me to be, I'm not a marketing guy. We have the use case at the center. That's the center of everything that we're doing. And then filtering out from that are the actors. And the actors define how we look at the use case. So if we take an example, the way the developer is how their processes are improved, how they can produce better quality, quicker, higher quality code, is a part of that developer journey, right? So how can the developer create better code as a result of the use case definition? Another example would be when we look at the CI/CD pipeline. What additional metadata does that pipeline need to ensure the functional safety, the real-time aspects, the integration requirements when we have multiple microservices all vying for access to a limited resource set in the vehicle? How do we ensure that we don't oversubscribe any interfaces in the vehicle? And the same thing then for the orchestrator. What does the orchestrator need to have available to it to help it deploy the workloads to the right place in the system, to the right part of the heterogeneous architecture, the Cortex A's and R's and M's that we talked about before? How do we make sure that happens seamlessly and independent of the underlying SOC architecture? And you see that that starts to form part of the story of how we can take workloads unmodified from one system architecture to another, because we're adding the intelligence to that orchestrator to say how the workload should be deployed and what its runtime requirements are, and how, you know, a real-time processor is needed for this particular workload, but we can get away with just running this one on an application core because it's just QM requirements. So that use case process helps us then to define, you know, the what it is we need to do. The next part of the process then is how we define a roadmap from that architecture document, from the use cases that have been defined. And actually, we've taken the approach to involve the marketing committee heavily in this decision process. And the reason we do that is that the marketing committee have good visibility of go-to-market requirements and commercial needs in the automotive domain. And they help us to understand which are the most market relevant features that are needed today to solve an immediate need, rather than me as a technologist saying, that's a really cool thing, I want to go and work on that, right? Which I'd much rather do, right? But Robert's going to help us to understand, and the marketing committee that he runs, going to help us understand which of the features of those use cases are needed first to give us the best initial impact for what we're doing. So what we end up with is a graduation from the architecture specification V1, which is on the left-hand side, all the way through to the architecture vision documents. And we are going to take arbitrary points along that road to make releases of the SOAFEE architecture as defined by market needs and market requirements. So we will make additional releases of the architecture specification, so V1.x, V2.x, and as I've shown along that road there. But they will also then correspond to releases that we will coordinate with the reference implementation working group of that reference implementation, EWOL, the reference implementation of SOAFEE, which means that we have then a mechanism to work with the wider community, so communities like AutoWare, to incrementally add new features that are compatible with that SOAFEE architecture. So we can make sure that what we're building is relevant to a real deployable solution. So in that blueprint space, we've got AutoWare at the moment. We would like to have others in the open space, so things like AGL, for instance, as an IVI stack. We're working with organizations like the eSync Alliance, where they're looking at building OTA updates, and we have a prototype of that working. And you can start to see then we can bring all of these components together as more microservices-like components into the complete system to build the functionality that we're looking at for that deployable solution. Right. Okay, sorry, I went too far. But this is my last slide. So I really want to get on to hearing what the working groups are going to be presenting to us. But I just wanted to go quickly over the structure of SOAFEE. At the top, with any open source project, we have the governing body. If you go to the SOAFEE website and look at the members page, it'll show you who the members of each of the governing body and the voting members are. I think we're currently at 58 members now, and that number keeps growing all the time. So in that governing body, we have people who are making the structural decisions around SOAFEE and how SOAFEE moves forwards. But the major work is happening in the committees that sit below that governing body. And that's in the Marketing Steering Committee, which is run by Robert Day, who just gave the last presentation, and the Technical Steering Committee that is run by myself. Now, in the bi-weekly meetings of the TSC, I try to run it so that we have the first session is a filter up of activities and engagements in the working groups and the Tiger teams. So we get a holistic view of progress across the whole of the project. But we also then use the end of the session for presentations by member companies of what they're doing with SOAFEE, the technologies that they'd like to bring into scope. So for instance, the last TSC we had was a very interesting presentation by Red Hat about the technologies they're building into their implementation of the SOAFEE architecture. All of these presentations are being recorded, so you can go and find access to them. We need to work out how we make it more visible and easier to search, though. So it's not, we're all trying to find our way through the Google Workspace at the moment, and it's not all of us are native Googlers. So if you need any help finding stuff, then please reach out on the Slack channels. And actually, that's a good point. So if you go to the SOAFEE.io website, there is a if you go to the About tab at the top, there's a page called Join, which explains how you can join the get access to the reference implementation, how you can join the working group meetings. There's the public calendar there. There's information on the Slack channel and all of those resources that are available. Underneath the TSC, we have a number of working groups and Tiger teams. Now, the working groups are the kind of primary business generating parts of SOAFEE. So we have 4 primary ones there at the moment. We have the System Architecture Working Group that is having a holistic view over the system architecture. And this is where the use cases first land to get their initial analysis. We have the Cloud Native Dev Working Group, and that's looking at the in-vehicle standards and technologies, the OCI, the CNCF, what needs to be augmented, changed, and modified there to make them relevant to the automotive, the real-time and safety domains. We've got the Cloud Native Tools Working Group that's looking at the delivery pipelines, the CI/CD processes, how to do virtual hardware in the cloud to enable shift-left technologies and all of that goodness, how we compile workloads multiple ways for multiple different target architectures. There's all sorts of interesting discussions and work that's going to be happening in that group. And then the final one is the implementation working group that's responsible for delivering us the EWOL reference. And they're looking at other aspects as well, like how do we do a validation and certification of SOAFEE implementations. You're going to be hearing from all 4 of the leads from those groups later in this session. Who you won't be hearing from are the Tiger teams, because we just didn't have time on the agenda. And Tiger teams are smaller groups that are set up to look at specific features under the TSC again. So the 3 that we've got there at the moment is the Mixed Critical Orchestrator Working Group, Tiger team, which is looking at how we deliver mixed criticality, different ASIL levels, different real-time capabilities from that orchestrator's perspective. We've got the hypervisor Tiger team that's looking at hypervisor portability and what that means. And the last one being the Eagle Tiger team that is looking at that, that moonshot project, as it was originally called, the big picture, how all of this comes together to create that compelling value within the SOAFEE ecosystem. So I think that's enough from me. I'm happy to hand over to the next presenter. I think we have Q&A at the end of this, don't we, Robert?
Yep, Q&A at the end. And as they start typing in your Q&A questions as we go through each of these presentations. I think now we'd like to hand over to Martin Stam, who chairs the System Architecture Working Group. Martin, I'm going to give you control of the slides.
Yeah.
I can get
I think you should already be able to hear myself.
Yes. Yep.
Now, in a second, I should be visible. Okay, great.
If you
so
do,
let's just check if it works for me. Doesn't seem to work. Can you go down one slide?
Yeah, I will do. I'll do it for you.
We make it via voice control. So basically, as sort of giving you a bit more of a context, why we are doing SOAFEE and what we understand under software-defined vehicle. I think that I would like to, from an architecture point, bring in, first of all, a few motivation and key factors which drive us doing SOAFEE. So, and putting together the points which make a software-defined vehicle ends up in a few properties I would give it to those. So first of all, it decouples software from hardware. So we are talking about starting with a software definition for the vehicle and then deploying it to different kinds of hardware. And that also means, of course, throughout the lifetime of the vehicle, the end user gets new software features. Next point, which makes up software-defined vehicles, is of course time to market. We want to bring new features in a much shorter time to market into the vehicles and into the vehicle fleets. And somehow this is of course linked to security topics. We want to be fast when deploying bug fixes, updates, and still reach the maximum maturity. In order to achieve that, it's pretty clear that we cannot really stay with the current decentralized way of compute architectures we have in our vehicles. So we need to centralize compute. That means it's a refactoring of the existing vehicle architecture, and we will see partitioning technologies being applied in the automotive industry. It's already in, but that will definitely grow. And of course, what we will see in the future, vehicles get connected. We will see distributed services, which makes functions for the end user from a combination of services from the cloud, from the infrastructure or edge, and from the vehicle itself. And that will definitely pave the way to completely new features. So can you go to the next slide, please? I think we already have seen the architecture overview, and basically I would give it from the perspective of SOAFEE two different main targets. Why do we set up this architecture? One target is, of course, that distribution of services. We want to work with an orchestration of vehicle services, which has QM and mix and safety levels. And we want to have services running in the cloud, working together with services running in the vehicle. And we want to be more flexible, maybe also in the vehicle where we deploy workloads. The next thing or next dimension which we want to achieve is more on the efficiency side. That means basically talking about this environmental parity. So we want to have workflows which start in a virtual environment in the cloud, and which then give us the opportunity to develop, test, and even at least partially validate those services up to a level where we can easily deploy those services, then into the vehicle and into the vehicle fleets. So basically, these are the major directions which we work on. And if you go to the next slide, I basically just put together a few of the topics where the system architecture work group currently works on. So first thing Matt was sketching already, that how we work with use cases. And basically, since we also want to work with prioritization of the use cases, this also means that we somehow need dedicated, at least overall standardized or comparable way how we describe use cases and how we formalize use cases. So we have defined a sort of template which we can use, which is accessible. Maybe that would be also something where we can put in the links to the documents. And we have also created a sort of golden sample in which indicates how we would like to have use cases described once we take them in for SOAFEE. That's basically a step in order to support the decisions in the MSC on the prioritization of use cases. We are currently working on architecture guidelines, which are more sort of adoption of the, for example, cloud native tray maps and also the 12-factor architecture topics into the automotive domain. That is also in a way linked to what is currently happening in the cloud native development work group. We are currently working and started a discussion about a SOAFEE trail map in a similar way how we see it in the cloud native trail map, to give the users of SOAFEE a sort of path, what they would need to do in order, also from the application point of view, in order to migrate their monolithic applications into microservice architectures. That's something which we have started. And of course, as already mentioned by Matt, we have those two documents, the architecture overview and the architecture vision. If you go to the next slide. Just maybe a few activities which we see on the architecture runway. So, of course, there is at least the architecture vision, which we somehow intend at least to create the next iteration until next year, January. We are currently working with the Tiger team on ways on how to do partitioning. Of course, hypervisor is not the only contribution to partitioning. We also have contribution of container technologies, and somehow we need also a bit of recites which describe what are best practices in terms of using hypervisor and container, respectively using those, and how do we deploy dedicated aspects of the system. We definitely need to continue also on the concept level to work on this mixed criticality and the orchestration. We have a work group, but there are also aspects like scheduling, planning, and other topics which somehow are across the different work groups. We definitely also need to cross-check the aspects around the telematics, giving us also means of really proving that what we assume in terms of parity between cloud and physical target is really also manifesting in the way we assume it. And of course, tooling is also in need on being integrated not only in the CI/CD aspects, but also as a means for worst case execution policies and stuff like this, since that is essential for the safety aspects in SOAFEE. And of course, really finalizing the trail map, which we started, would be one of the next steps for the system architecture work group. And I think with that, I'm passing already to the next participant, not participant, presenter. I think that's from it's Neil and Konrad, right?
That's correct. Thank you, Martin. Neil, I'm going to give you share control now.
Okay, awesome. Let me see. I'm able to move it. Okay. Okay, it's working. Thank you, Robert. Appreciate it. Greetings, everyone. I'm Neil Mitra. I'm a principal solutions architect at AWS. Overall, 18 plus years worked across different industry verticals. And my current focus is to help build the next generation of software-defined vehicle products and services. Very excited to be part of SOAFEE, and I look forward to working with all of you. If not, I have met some of you, and solicit feedbacks to craft our software-defined journey forward. I'm trying to move the slides. Okay, so based on the earlier poll, I think we saw more than 30% of you are considering to move to cloud. And generally, a common question from cloud newbies is, what is cloud native? So I thought to address the elephant in the room first. As you can see on the screen, the definition from Cloud Native Computing Foundation on what cloud native exactly is, right? So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid cloud. And that includes different kind of technologies and design patterns and best practices that we have learned for many, many years now, starting from containers, service mesh, microservice, immutable stateless infrastructures, API, and whatnot. Now, before you throw it away as another buzzword, I'd love to emphasize that cloud is the new normal. For more than a decade now, it offers a massive scale of economy, enables rapid innovation, and democratizes access to any technology that exists today. Thus, at SOAFEE, we started exploring how cloud-native design can accelerate the journey towards software-defined vehicles. So as we started this exploration, what we realized is the core fundamentals behind the cloud-native philosophy is actually based on distributed computing and service-oriented architecture that many of you are probably familiar with. So as a service-oriented architecture, you build business capabilities which are nothing but functional services designed as APIs. And an evolution of service-oriented architecture is referred to as like a microservices pattern, which is essentially a piece of code that does one thing really well and can be deployed and orchestrated on location-agnostic compute systems. Rings a bell? Sounds like easy, right? Okay, so let's dive deeper. So if we navigate from left to right in this picture, the goal essentially is to evolve from a monolithic design to more of a service-oriented design that is very popular and common in the IT and the cloud computing environments. Now, all these applications that Martin just talked about and Bill touched upon it as shift left, it can run on same OS, different OS, as long as the hardware and software stays decoupled. You really do not care about the application layer, and it can be updated over the air throughout its lifetime, right? Which is pretty cool. So at the same time, though, we do get that car is not an iPhone on wheels. We get that, right? Automotive computing has certain special requirements that typical IT or mobile computing doesn't have, which is real-time control, functional safety, often referred to as mixed critical workloads. Thus, it's going to be an evolution and a journey for all of us to learn from each other and figure out the right cloud-native principles. And as SOAFEE, as Matt mentioned earlier, our objectives are to reuse open standards, right, for different components in the framework, and will extend those standards as necessary to meet the requirements for mixed critical automotive applications as well. Okay, I'm again trying to move my slide. Okay, so I think Robert also touched upon it, that with more capable, heterogeneous, purpose-built SoCs on the horizon, there's a trend towards further consolidation of ECUs and domains, wherein high-performance, embedded, ruggedized, native servers will replace the domain controllers and pave the way for this new EE architecture that we are calling zonal architecture these days, right? And you have seen this architecture diagram multiple times, and we'll show you many more times until we ensure it's snapped to your mind. But essentially, we're talking about a major shift and transformation in the way automotive applications can be developed, tested, and deployed, right? Shift left, essentially. And we take advantage of environmental parity between the edge, which is the vehicle, and the cloud. And that essentially helps with the agility of the whole V model, essentially, right? So this is like a high-level view of the automotive central compute solution stack, showing you the hardware, the software, and the cloud levels, which stays vendor agnostic. And the mechanism of cloud native development and deployment will apply to, as you can see, all the QMs or ASIL services running different kind of runtimes and hypervisors, deterministic, non-deterministic. But the question is, generally, okay, that's great, but where does, how this happens, right? Like, how does the robot meets the road? So that's where the cloud native design principles comes into the play. Let me move the slide again. Okay. And what we did essentially, we stepped backwards a little bit to learn from the rest of the industry. Sorry. Yeah, we stepped back a little bit and to learn from the rest of the industry on how we can develop the next generation of automotive grade applications. And we use 12-factor methodology, which is very popular in the software as a service world, which can essentially be applied to any applications written in any programming language. So we use this as a baseline and then spend non-trivial minutes diving deep to determine how many of this is relevant for automotive. Surprisingly, we found out most of these principles on the screen in some way or the other is relevant. Some in use today, such as logging, managing dependencies and configurations, disposability, etc. And others are new, but is kind of required in the HDV ecosystem. So things like environmental parity that lot of the previous speakers touched upon, DevOps from the cloud to the edge, different kind of backend services. It's still a work in progress though, so we are still finishing our assessment, and we aim to publish a collateral regarding our research and findings next year. But based on these discussions, it became evident that the topic of containerized workloads, along with mixed critical orchestration, needs a lot of research. And that's where we created a Tiger team that branched out of Cloud Native Working Group, and we call it Mixed Critical Orchestration Tiger Group. And Matt kind of touched upon a little bit, where we have various companies, as you can see on the screen, are working together to have a point of view on the mixed critical orchestrated workloads using cloud native design principles. So with that, it's a pleasure for me to invite Conrad now, who is leading this Tiger team and will share a lot more details around their efforts. So Conrad, stage is yours.
Thanks, Neil. So also warm welcome from my side. I'm Conrad, I'm with Continental, and I'm leading here innovation projects for the software-defined vehicle, and also am chair of the Tiger team for mixed critical orchestration. So let's see. So what is mixed critical orchestration all about? So in general, for the basic understanding, what we want to achieve is that we have a software component that is able to run safety and non-safety workloads in parallel while having cloud native technologies enabled. And all of this, of course, we want to do not in the cloud, but in a constrained environment, which is a vehicle. So we also have to consider automotive functional safety requirement as well as real-time requirements. So in general, what you see as a basic stack is that you have some automotive hardware running, or even multiple. Then you may have a hypervisor there that is partitioning the system. You have several operating systems running in parallel. So one of it might be a safety certified operating system with also real-time capabilities, and the other one might be just a quality managed system to run quality managed workloads. And in order to manage and orchestrate workloads across these operating systems, and even on single operating systems, we want to have this new centralized components, the mixed critical orchestrator, established. And this is what the Tiger team is about, to find possible solutions and also standardize on interfaces, standardize on how we implement this so that we can run applications in the same manner. Next slide. Yes. So to give you an orientation, this is the architecture picture. We saw that quite often now. So here you also see the same architecture boxes. They are directly the SOAFEE framework. You see there the container runtimes and the mixed critical orchestration. So they are really in the heart of the SOAFEE framework. So this is what we like to achieve here, that we align on this core components of the safety frame of the SOAFEE framework, and align also there with other working groups how to make this happen and enable these basic concepts. So we started already some months ago. So the first things which we did in the group were that we aligned on available solutions and concepts and discussed them within the group. So we had a very nice presentation from the EOS system for mixed critical orchestrator concept by EPAM. So we'll find a presentation tomorrow, which goes in details of this. We also had a look into the K3S solution by SUSE, which is already meant for embedded systems to run the workloads. We also have presented the solution North Star by ESA Labs, which is used within Carriot and also enables containerization for automotive systems, and also some memory innovations by ARM, which fit into that picture too. So what we saw out of this first presentations is that mainly the existing solutions on the market, they are not fitting the requirements which we have towards mixed criticality. So especially for real time and for safety, there is still missing gaps. So we need to enhance them or even bring up new concepts. Also, we have new concepts brought up by EPAM. So really, we need to figure out here if they fulfill what we have as requirements, especially towards timing. So we shared that first information, but of course, we need to deeper go into the details. And what we also did is we shared our common progress. So we see several companies, several partners in SOAFEE are working on these topics, and we share the results of that in the working group. So we talked about taints and tolerations, how to use this type of concepts from Kubernetes inside the automotive environment, also how to connect to adaptive AutoSAR, for example, via SAM-IP and demonstration of this. So you see something tomorrow from Electrobit in that area. There was also benchmarking done of components from K3S, where we saw that, for example, Kubernetes itself, the component has about a 20% workload overhead, which we cannot tolerate that easily in the car. So we need to figure out if we can optimize also the cloud native technologies. And we also had to have a look into the OCI standards and gaps and where we need to modify them according to fit in with the mixed critical orchestration. So if we look into the results of that, we already identified there are several big challenges which we need to solve. Some of them we can directly influence within the group. But one major challenge is, in general, we want to run containers in an automotive system. So if you want to build an established system like adaptive AutoSAR, for example, we still miss the support for containers or pods in general. So we don't have cloud native interfaces. So the systems that are in serious production, we cannot easily just use because they miss support. On the other side, if we want to use a Linux system for mixed criticality, then we have container support, but we are missing real-time aspects, or we miss also certification for a safety certified automotive Linux. So both build the fundamentals of where we can run our system on. So both of it we are currently missing, and there are projects really working on those topics and getting things started. But this is somehow something we need to build on. The second thing, which is a big challenge, is that there's currently no safety certified implementation of a mixed critical orchestrator available. So we saw there are some solutions in the market, but they are not built for safety certified use in automotive. There's new concepts upcoming, but here really we miss a new component that we need to build together, or as one of the members that we can discuss be part of the reference implementation. So especially looking into runtime and scheduling, and also identifying closely which one needs to be certified to get the automotive certification. So if we have to certify the whole mixed critical orchestrator or only crucial parts of it. And finally, what we identified is also that the footprint of cloud native technologies which we want to use needs to be optimized. So key performance indicators, of course, the container startup time, but also CPU and memory overhead, or the container sizes, which the layering structure which is currently used is often too big. So we need to find out the good solutions how to optimize all of this. So especially looking into container startup times, this is, I think, one key factor to enable and remove blockers for the mixed critical orchestrator to be used in the future vehicle architectures. And on this type of challenges, we currently working on. So to come to a summary, what we are doing. So on the in the mixed critical orchestration, our current step is that we consolidate requirements which we have received from all members for the mixed critical orchestrator itself. So getting a document together, what is important for us, and then work on the challenges one by one, as far as we can influence them out of the group, for example, by executing proof of concepts. In parallel with the mother group from the Cloud Native Dev, here we have the 12-factor application analysis done. So the next step is here to publish this design principles for the Cloud Native design. and how to use it in automotive. And of course, at the end, we want to collaborate and execute and exchange here with the other working groups on the use case basis, for example, and deliver here tangible artifacts that we move forward within SOAFEE. And that's it. And I'd like to hand over to the next.
Okay, thanks, Conrad. Over to you, Leo. I'm
Do you want me to take over or just?
Just say when you're on the next slide, and I will advance.
Okay. So hello, I'm Leo from Red Hat, where I work as a principal engineer, and I will be talking about the Cloud Native Tool Working Group, what it is about, what we're currently doing, and what are the plans that we have for the group. Next one, please. So just a brief list of the topics we'll be talking about today. So as I said already about the group, what's the current state, what's the plan ahead of the group, and where you can find us to join us, contribute to whatever you want to, and so on. Next one, please. So about the group overview, as I said, it's about cloud native tooling. So there are several aspects of this group that has a lot of synergy with the cloud native development group. But I believe that there are three main pillars, foundational pillars of the group, which talking about both discussing and implementing DevOps methodologies to the automotive industry, which includes from using existing tooling or ways of doing cloud workloads for the auto edge devices. There's a big topic on auto edge workloads. So how do you deploy and update a running application? Do you do it on system reboot? Do you do it on live? How do you deal with the container workloads from a tooling and workload standpoint? And there's the big topic of CI/CD workflows as well. How the group can contribute to testing car applications. About it can be from just your usual tester application, build it and then make it available for update into a running edge device. About testing the application on the cloud, emulating or simulating the car hardware. So embedded engineers, they don't need to. They can leverage cloud services to actually test their applications and actually have to have the specific hardware or collection of API features in their local development environment. And last but not, and yeah, next one, please. Current state, and the group has been moving a bit slowly, mostly focused on bringing up members and partners presentations about their own what we call integration lab implementations, or how their SASD workflow works with the SOAFEE's own reference implementation, also referred as ELO. And we're also would encourage to watch those presentations because they're very cool and nice. Next one, please. So what's ahead of the group as planning, or as said, as next year we're moving more for execution phase. So this is definitely where the group would shine more about contributing to existing use case and the blueprints, how we can contribute from a tooling standpoint, either make more work on how to test applications in a standard way, or how can we contribute to blueprint? How can blueprints implementations be tested in more of an automated way from maybe from a SOAFEE integration lab, maybe. And as I said, working closer with cloud native, the cloud native development working group on the reference implementation one as well. Yep, next one, please. So where you can find us, we have a Google group for the tuning work group in case you wanted to engage in more of an asynchronous way of communication, or you can find us in the SOAFEE Slack instance in the Cloud Native Tools group. And that's everything.
Okay, thank you, Leo. Okay, I now need to do a quick stop share and reshare. Give me 1 second. Okay, the reason I had to do reshare is I had to turn the sound on. Unfortunately, Anmar could not join us today. He's on a flight, so he actually recorded his presentation. So I'm now going to try playing it, and hopefully we will be able to hear the sound.
Hello, everyone. My name is Anmar Aweja. I am the Reference Implementation Working Group Chair at SOAFEE. I'm talking to you from my lovely hotel room here in Cambridge. I've been on a 10-day trip, and I apologize for my voice. I've had a bit of a cold, so I will spare you the details. And well, let's just get started. So for the uninitiated, I think it's important that we highlight some of the goals of the Reference Implementation Group. I don't want to bore you with a lot of slides. I kept the slides down to a minimum to focus on a status update, so everybody kind of gets a bird's eye view of where we are at, what we've done. But I think this slide does kind of frame the context of what is our mission? What is it that we are trying to do? Currently, and we're expecting things to, of course, change as they improve, but overall, these 3 valid points will stand for several months, if not more than a year. First item will be to improve support and enhance the edge workload abstraction orchestration layer. That's quite a mouthful, which is what we call EWAL. EWAL is the reference implementation of the SOAFEE architecture, and in order for us to support it, it is the target of all our development, exploration, investigative type development, testing different workloads, providing the support for blueprints and what have you within SOAFEE. EWAL is absolutely instrumental and central to that. And one of our goals is to make sure that it is well tested, it is kept in a high quality state, well documented, as it grows and improves, and also to host and manage the quality of the code by monitoring merge requests coming in with additional features or bug fixes or whatever the case might be. The second item is validate use cases on EWAL targeting specific hardware platform in the SOAFEE integration lab. The reference implementation work group has what we call a SOAFEE integration lab. It is hosted by Lenaro in the Cambridge offices. And what it does, it provides a high level, a place where we can actually have hardware and leverage a lot of the CI experience in Lenaro in order for us to run tests, be able to make builds, run those builds, boot them, run some tests on them, collect the results, and keep an eye on the quality of the entire stack. So that's one of the big mandates of the reference implementation working group. Finally, we're also started recently the SOAFEE compliance test suite development, and that will continue to happen over the next several months as the SOAFEE architecture specification is enhanced and improved. Apologies. Update. So what have we accomplished so far? It's been a few months. Teams have been busy. There was a lot of scaffolding that was being put in place, a lot of core pieces. We've spent a significant amount of time putting a lot of pipelines in place, build pipelines. We have a nightly pipeline, and we have a per push pipeline. So if somebody contributes any changes into eWall, their merge request will automatically be merged into the tree, merge into a temporary tree, validated, and then it will speed and simplify our ability to review merge requests and assess their impact on eWall. And that's very important for our development and the work and the team that's working in the reference implementation working group to make sure that they maintain the quality of the code. We also are making the builds targeting multiple platforms. And in a perfect world, there will be one generic AR64 platform. But for now, we're kind of learning to walk before we run. We have several platforms that we're targeting. Most important ones will be the AD-Link, the QEMU, generic AR64, and probably the Raspberry Pi for the community. As I mentioned, one of the goals is to validate and test the platform, the eWall on hardware, and that will be our primary platform right now is the Ava developer platform. But in order for us to do that, the platform itself has to be integrated into what we call LAVA. LAVA stands for the Narrow Advanced Validation Architecture. It is very well known. It's been around for many, many years. And it is a way for us to install an image, interact with it, deploy builds, deploy tests inside the builds, run the tests, collect the data of the tests, and what have you. So it gives us a complete automation framework for us to interact with the board in a repeatable, reliable fashion that yields the results that we are looking for. So that work has been done. It took a little bit longer than we planned, but unfortunately there were a myriad of external factors that affected that. But that's actually is now done, and there's a staging. As a matter of fact, there's an Ava platform in the staging instance of Lava that we are using to test the waters with. The Ava platform, for the people who don't know, are basically a big tower box, looks like a PC tower box that you would put under your desk. Unfortunately, that form factor is very unfriendly for an automation lab like so what one of the things that we have been in the process of sourcing and shipping and getting it up and running, and I can say that this is actually, as we speak, in the next few days, that work will be done, where we're going to be transferring the Ava platform from a tower desktop into a 4U chassis, so we can rack it in a Lenovo SOAFEE integration lab and start targeting it for our automation testing. So it's exciting times at the moment. Finally, we created a test framework to host the SOAFEE compliance test suite. With the SOAFEE architecture coming online, we feel it's very important that a compliance test is in place in order for us to identify more than just eWall as a SOAFEE compliant implementation. That could be a Fedora or a Red Hat or CentOS or Debian, whatever the case may be. So we have finished we created a framework. The framework basically can run on pretty much, any repo. You clone the repo and run it. And in the future, we can probably offer some RPM and .deb packages. But it's very straightforward. It's meant to be lightweight and straightforward. And we are going to start with the framework done. We're going to start looking at adding actual tests into it. Finally, just for everybody as an FYI, all the eWall and the Meta eWall layers and the Meta eWall machine layers all have been migrated into gitlab.com/SOAFEE/eWall. It's bounced around a couple of places, unfortunately, because we needed to get moving and the SOAFEE account on GitLab wasn't ready, but now it is, and that's all very good news. So what are we working on right now? Right now, we are targeting the EWAL image boot testing on the AVA platform. We've did EWAL many times to kind of flush the pipes on a QEMU, but the target has always been the AVA developer platform. Now that we have it in staging, we know that it is working. I've heard from the engineers a few days ago that it is, and but it's not done until it's done, and that is the production instance. Once those AVA platforms in the 4U chassis go into the lab, and our hardware team, our hardware lab team has vetted them and comfortable with them and secured and reliable, we will start targeting our pipelines at those devices and see how once things are green light, we will be able to move on to the next item, which is to develop, to deploy the OpenAD blueprint tests. We're working with the OpenAD engineers to identify specific scenarios that we want to capture as tests and run them. And that should hopefully happen relatively soon. We understand the situation, we understand the scenarios we want to test. It's just a matter of what's the best way to go about it. So we don't anticipate this to be any major issue. Finally, with the SOAFEE compliance, the SOAFEE framework is being complete and ready. We think we are ready now to start adding tests. And the plan is, as we add tests, starting with the simplest ones, we are going to enable them in the CI loop. And the objective here, obviously, is to make sure that whatever we're adding is not breaking the test themselves and the test framework, but also to start running them in EWAL and see, if there's any issues that we identify and what have you. And that will continue to exist for quite a while now. Those tests more tests will be added as the specification increases. That's it in a nutshell, what we've done and what we're working on right now. I hope that gives you an idea of what was accomplished. If you have any questions, if you have any requests, feel free to reach me on Slack on the reference implementation working group Slack channel, or you can ping me on email and I'll be happy to respond. In the meantime, I apologize. I cannot host a session live as I will be flying back home, but I hope this answers most of your questions. Thank you very much.
Okay, thank you, Anmar, for sending the video to us. We are actually ahead of schedule, which is great. Hopefully, like your software development will be when you use SOAFEE. We now have a break. Okay. Welcome back, everybody. I'm assuming you all came back. And we're now going to start the last session of the SOAFEE Symposium Day 1. So we're going to kick this off with some details about blueprints, which you will have heard a little bit about this morning, some stuff about integration labs, a little bit about how we're looking at the SOAFEE roadmap and the different components of the SOAFEE roadmap. Then we're going to talk about how we're working with other initiatives. And then finally, how you can get involved with SOAFEE and also answer the questions going to the Q&A at the end with the panelists. So as I said before, I think this is going to be, showing you how you can really start to utilize SOAFEE and get involved with SOAFEE. So Daniel, I don't know if you want to pop video on. Daniel. Okay, we'll have a pause while Daniel comes back. Oh, here he comes. Jeffro, you're on. Good.
Can you hear me?
I thought I'd lost you, Daniel.
Yeah, sorry.
Welcome back.
my window got lost. I apologize.
It's okay. I've given you control, so you can try it. If it doesn't work, I'm happy to help as well.
Yeah, I'll just say next slide.
Okay.
Okay, so yeah, thanks everyone for joining. My name is Daniel Bernal. I'm part of the ARM team supporting SOAFEE. I work in the automotive applied technology team, and I lead the Project Eagle Tiger team. So very familiar with Blueprints and Integration Lab, and that's what we'll be doing today, is talking about that specifically. So next slide. So next slide as well. Yeah, you heard this description earlier probably, but Project Eagle really is about demonstrating DevOps in the cloud and deploying at the edge. And we do that with a couple elements that we are going to introduce you to today: Blueprints and Integration Labs. But first, we felt it was important to kind of share the details, or what the detailed goals are for Project Eagle. It's really about providing a repo of automotive workload examples, right? And these workload examples are what we will use to kind of pipe clean or demonstrate the architecture and the DevOps in the cloud and deploy at the edge. We will, set up an infrastructure or kind of a playground to showcase and cross-pollinate technologies between multiple SIG members. And really the goal is to identify any gaps, right, or any technology issues that we encountered during this process, right? So it'll reveal things that we need to work on long-term, as far as reference implementation and ultimately the architecture of SOAFEE. And it is an integration point, right, for multiple consortia to work together with examples, working examples. And it also provides a infrastructure to deliver incremental SOAFEE SIG releases, right? And by release, we mean architectures which drive the reference implementation, and then example workloads that actually take advantage of that reference implementation, or our partner implementations as well. And we'll discuss that. So next slide. So I mentioned this DevOps in the cloud, deploy at the edge. And it's really the goal here is to adopt cloud developer ops, right? The developer ops model of continuous integration and continuous deployment. But the goal here is to do this with examples, working examples. I'm not going to dive too much into the concept of microservices, but at the end of the day, the working examples that we use as blueprints, the goal is for those to be deployed as a service-oriented architecture or microservice-based architectures that we can deploy using the SOAFEE architectural elements, right? Containers and deploying containers at the edge. The concept of SOAFEE Integration Lab, which I'll dive into a little bit deeper, right, is really how we validate on target hardware. We can do all the development we want in the cloud, but at the end of the day, it needs to be validated on target hardware before we deploy at the edge, right, in mass production. So that's what the SOAFEE Integration Lab facilitates, and we'll dive a little bit deeper into that. Next slide. So what is a SOAFEE blueprint, right? It's initially we started this journey with a blueprint as it being an open source reference application software solution guided by specific automotive software defined use cases, right? It's really and to validate the SOAFEE architectural concepts. But at the end of the day, it's an example application that uses a SOAFEE architectural compliant implementation, right, to accelerate development, and you can use it for prototyping, and you can even, if it's open source, you can adopt it in your product if you really wanted to. We are planning to extend this to have example applications that aren't open source, right? But we'll have to work through the details on how you share that as an example, because we are providing repos where people can just clone a repo and off they go running to test the application, right, or prototype of the application. A couple of blueprint examples. I'll share more details about this autonomous driving software blueprint called OpenAD-Kit. And then there's plans for digital cockpit blueprints, and quite a few other partners have blueprints in their pipeline as well, and we'll share those as time moves on with SOAFEE. Next slide, please. So the elements of a blueprint, right? And it's pretty basic. In the right side, you'll see that it's an application specific workload running on a SOAFEE compliant or reference implementation that provides the features to run that application. And the key thing is to run that on and validate it on a standards compliant firmware, right? And that's what System Ready will provide you, right? And the goal is for the platforms that we support with our eWall software stack, those will be validated on this standards compliant firmware. And so if you design your blueprint or run it and validate it on the eWall, then you'll be doing that. And then if it's something you want to do on a partner implementation, which those will be available as well, then that's something that's an option for you as well. Next slide. So I mentioned OpenAD-Kit as a blueprint. We're calling it officially AutoWare OpenAD-Kit Blueprint. This is the initial release. We will be releasing it, and it is available on our GitLab.com/SOAFEE repo. This is the 1.0 version of the AutoWare OpenAD-Kit Blueprint. So the journey to migrate AutoWare, right, as a monolithic application to a more microservices or container-based application, it's a long journey, right? And so initially, it was very easy for AutoWare to basically clone, containerize the entire application, right? And that's why you see all four processes: mapping, perception, planning, and vehicle interface, all in one container. And so what they did is they duplicated the container 4 times and only ran one of those processes in each of the containers. But it proved the concept, right? That you could deploy these as multiple containers, and you can run them in multiple containers. This is the 1.0 version. This has been validated to run on the Ava developer platform from AD-Link. And the AutoWare Foundation and their OpenAD-Kit consortium, they have their own cloud-based development and build pipelines that they set up and build these containers. We just happen to be using their containers to prove this concept. So that is available today and on the GitLab repo, as I mentioned. Reach out to us if there's specific interest on this. If you go to the next slide, they are actually migrating to this, right, where they have more leaner, smaller containers to deploy. That's something they're planning to do in their roadmap. And so the next step, when we release an update to the blueprint, will be a little bit cleaner, with smaller containers that people can take advantage of as well. Next slide. So integration labs. This was something that was mentioned by Anmar in his presentation, the reference implementation workgroup. He did introduce kind of the concept of integration labs as a vehicle for testing eWall, where they have set up their build pipelines and test infrastructure on specific hardware. And he provided a list of hardware. That's what's in the SOAFEE Integration Lab in Cambridge. But the goal for Project Eagle is for us to test these blueprints, right? Not only run the blueprints, develop and run them in the cloud, but also deploy them at the edge. And these edge examples will be tested in SOAFEE Integration Labs initially. So the platforms that we will be testing on are integrated in this Cambridge SOAFEE Integration Lab. We will be adding additional platforms for specific partners who wish to integrate their device under test in our integration lab. And then there's also opportunities for partners to stand up their own remote lab. There's several partners who have shown interest in doing that as well. So that's really the concept and the goal for SOAFEE Integration Labs. Next slide. So I mentioned, or Enmar mentioned, in the SOAFEE Integration Lab, they're doing feature development and testing of eWall. And it provides an infrastructure to do regression testing for the reference implementation on the platforms that are currently supported by eWall. But it also provides the ability to test blueprints on top of eWall or a partner implementation, specifically on those hardware targets. So at the end of the day, it's really about proving and validating your DevOps workflow and deploying at the edge. And that's what the SOAFEE Integration Lab provides, an infrastructure for. Next slide. These are some of the open source tooling that is used for the integration lab. Anmar mentioned Lava, but there's some other tools. I'm not an expert on these tools, but they are very commonly used in the industry as open source tools for testing. If there's specific questions on this, please reach out in the SOAFEE reference implementation Slack channel. There's plenty of folks from the reference implementation work group monitoring that can answer questions in more detail. Next slide. So to wrap up on SOAFEE Integration Labs, you've seen that blueprints are not only very important, right, to driving the validation of the SOAFEE architecture, but also essential to proving the concept of testing and deploying at the edge. The goal is for the infrastructure and if we can to make the application open source. And the blueprints are very purpose driven, right? The scope of the blueprint is really to prove a application level use case that we can share with folks and other companies so they can use that as a springboard for their development and testing. We do require a certain level of documentation with a blueprint. And if you go see the the Open80 blueprint, you can see that there's a very detailed documentation on how to run it, how it's been tested and run on a specific target platform. And we will expect the same level of detail so people can use blueprints in a way that's purposeful for their use. We are providing community support through the Slack channel for blueprints, and ultimately we want folks to adopt these as prototyping and product development vehicles for their specific items. At this point, I'll turn it over to Jeffro to provide an update on the roadmap.
Good morning, everyone. I'm Jeffro from Red Hat. We'll go to the next slide. We can take a look at. I want to first emphasize this is a draft roadmap. This is kind of the first edition of it, and the idea was to create simply a graphic representation showing where the project has been and where we're going in the near future. So I think that most of this is pretty self-explanatory, and frankly, if it's not, then the roadmap is not created correctly. The items in green are the use cases that have been referred to. These are the ones that have been submitted to the architecture committee. They're drawing straight off of the architecture spec 1.0, which will be released with the upcoming SOAFEE release. In a separate swim lane or track, we've got EWAL, which is obviously the reference implementation of the specification, all of the ideas that are being described in the architecture specification. There'll be validation test suites that are released along with R2, the R2 release. Zen as a hypervisor is being released there as well. You can see in the blueprints, we've got the AutoWare AD kit, which has been submitted. I don't know if we've got another couple of them that are going to be actually submitted between now and the actual release, but if we do, we'll get these onto the roadmap as well. And the idea is to have this roadmap available for as a slide for people to speak to if they want to speak to it internally in their companies, and also to possibly to display it on the website, which I need to work with Matt about. Finally, the lower swim lane is partner implementations. You can see that Red Hat's automotive stream distribution from CentOS is on there as being compliant with the existing architecture spec. It also includes the AutoWare AD kit. We want to make sure that that's in there. And we're hopeful that other partner implementations will be available soon as well. The specification accommodates a large number of possibilities for partner implementations. So I hope that that's all clear. And if there's something here that you would like to see differently, or if you'd like to have other items displayed on here, eventually the goal for the roadmap is to have it probably over multiple slides to drill down into some very specific detail and possibly to answer some of the questions that I see coming up in the Q&A, which we'll cover in, I guess, about half an hour. So, all right, Daniel, back to you.
Are you done, Daniel? I think so. You're on mute.
You're on mute.
Oh, the other Daniel. Yes. Okay. So hang on. Let's move on. So the next session. So just a quick recap on that roadmap. It's been really interesting knowing what SOAFEE is, in that it's not just an open source reference implementation. It's an architecture. It has, all these different components to it. Having a roadmap's actually been quite tricky to kind of get onto one slide. And I think Jeffro and Daniel actually did a good job doing this. What will become interesting as this gets populated with new blueprints and new hardware and new partner implementations, it might well be that this becomes a multi-slide roadmap. But for now, we managed to kind of get all the concepts onto one. So last topic we really want to talk about today is how we work with other partners. So I'd like to bring Daniel Krippner on from Bosch. And Daniel, I'm going to give you, do you want slide control or do you want me to do it?
Let me try if it works.
Okay.
If it doesn't, you are on. Okay, I clicked a button. All right, here we go. That was me, right?
Yep.
Okay, hello everybody, welcome. My name is Daniel, also Daniel Krippner, working for Bosch, and I'm primarily, let's say, keeping myself busy in the context of two initiatives. One of them is SOAFEE, the other one is the Eclipse STV working group and the things that are connected to that. And I'm responsible for the gossip section today. So I'm going to give you like an overview and some news and some, goings on in that larger community that is surrounding SOAFEE, and that SOAFEE is well, has been working towards becoming a part of in that recent year. So I don't know who of you have been on for that first big community event that we did. I think it was about a year ago. And we also began already there. We began to speak or to talk about the fact that we are not alone in this universe and that there's others out there, in that neighborhood. And this is a slide that I opened that session with back then. So today we are going to have a couple of snapshots, highlights of what happened since. And we do have quite a control lag here. Let me try once more. All right. Okay. So we have been trying to get this neighborhood into some form of useful visual shape form. It's not easy. This is one that we settled on, at least for the session today. And it's not supposed to be complete or anything, but it is supposed to show all the different organizations, and bodies, communities that are flying around in this neighborhood, and some of the links and the goings on that have been establishing themselves in the course of this year and also earlier. You can read the labels for yourself, but essentially how this started was that back then, again, about a year ago, when SOAFEE initiated itself, one of the first workshops that we ran, little 1-2 hour session, was we invited a bunch of people from all of these organizations, everybody who wanted to join us, and just for a kind of meet and greet and say hello to everybody and give a quick intro of what the organization is doing. And the scope of people that were attending that session, that has informed the picture here. Like, this is where the names of these organizations are coming from. So obviously we have SOAFEE, the interest group, we have Covisa, we have Autosar, we have Eclipse, the Eclipse Foundation, especially the STV working group. We have Autoware, we have MIH, AVCC, we have especially for us as an upstream, a lot of work from the Linux Foundation. So that is a scope that we're looking at. And I'll give you, as I said, I'll give you a couple of highlights, spotlights now of what is happening. Some of these arrows, some of these connections that we can see here. I am going to start with the two. Oh crap! The layout of the barcodes is broken. Anyways, I'm going to start with the two that are closest to my heart right now. Let's say I know most about these two. Which is SOAFEE and the Eclipse Software-Defined Vehicle Working Group. These two are, let's say, well, not special, but what binds them together is that they started their work almost exactly at the same time. So both of them are about a year old now. And there have been conversations between those two groups also from day one, or essentially even before that. So these two have known about each other forever, essentially, since they existed. And both of these groups have now spent this first year of their existence, to kind of find their feet and begin to create the first couple of deliverables and artifacts, etc., whatever the groups are doing. We've heard a lot of what SOAFEE did already. In Eclipse, it was kind of similar. Eclipse had a bunch of community events where different organizations and groups of people contributed code, like projects. And one of these projects, the Chariot project, was actually also the first to reach out on a project level, work level, code level, to SOAFEE, to the eval reference implementation, about connecting and doing things together. So that has already started. Other direction, the other way around, we had another hackathon. We had two hackathons already this year from the point of view of Eclipse STV. The first one was the EclipseCon in October, and the second one was last week, the Bosch Connected World Hackathon in Berlin. And SOAFEE was present there. There were guys from the SOAFEE group and SOAFEE projects that were there and that were kind of part of that hackathon. And there's a couple of pictures, you know, and the usual LinkedIn post things that are copied below. But that was kind of one of the first, you know, physical getting together and actually doing things together beyond, you know, beyond meetings and beyond PowerPoint. So that was a great event. And now going forward between those two, I think we do have a bunch of potential that we need to kind of pick up this year. And the most obvious one is, as I mentioned, Eclipse SDV is getting together something like, you know, a first instance, a first iteration of their software stack, you know, where things also are being plugged together, begin to make some sense together. And I believe, and you know, this is something that we have to kind of discuss and make that belief a bit broader, hopefully. I believe that this is a perfect blueprint that could live in SOAFEE or with SOAFEE as a foundation of, alongside the others that we have seen already. So, you know, that's one of the things that I hope we can kickstart in the next couple of months or something. Another kind of highlight is the trio, really, in this case, between SOAFEE, the Autoware Foundation, and MIH, the Mobility and Harmony Group. So both of these, MIH and Autoware, both of these are already members of SOAFEE for some time now. And we've already heard about that just now. So there is work already for some time now to connect the OpenAD kit, which is the Autoware stack, to connect that with SOAFEE by, you know, making it one of the SOAFEE blueprints. We do have sessions on that tomorrow, which essentially even two. So we have something where, you know, about what I just said about that connecting the AD kit on top of the SOAFEE reference implementation. And we have an addition to that from the Red Hat guys, where they show what happens like when you shove the Red Hat CentOS, the automotive stream CentOS distribution underneath to get something that's, you know, even like closer to a vision goal of what an automotive open source stack might look like. And the connection, or like the link that's been starting towards the MIH guys, is that also they have started picking up the OpenAD kit for their OpenAV project. Again, I apologize for the QR codes kind of being offset at the top. We are just losing the N word for now, but if you are interested, any of these organizations, you can follow the links, you can scan the code. There's a lot of things out there to look at. Another one, well, okay, another couple of ones essentially is SOAFEE in general, looking at some of the more, well, early or, you know, intangible links that just started for now, or maybe also looking at the Linux Foundation. I mentioned that Linux Foundation carries a lot of tech that a lot of communities are using, and this is also true for SOAFEE, right? So eval, there's been a couple of keywords mentioned already. Eval is heavily using Kubernetes and container technology in the reference stack, you know, via K3s and container runtimes, etc. We are using Sen, which is again something that's upstream, or well, that is picked up from Linux Foundation upstream. We are using Yocto to build the reference images. So all of this is Linux Foundation tech, and obviously, you know, that's kind of non-surprising, but that does create a very direct and broad link between those organizations, even if it's in that case mostly a kind of unidirectional thing. However, there has been already also an outreach and discussions started specifically with the automotive grade Linux project that lives in the Linux Foundation, because, you know, that's kind of together with SOAFEE, with Eclipse SDV, that is a very, very focused and specific automotive thing. So this is one of the, again, in my opinion, one of the higher prior topics going forward, next 2-3 quarters maybe, to identify between those 2 or 3 groups some, you know, some useful collaboration picture to reduce confusion and to make it clear like what the synergies are and what the mutual benefits can be. And that's something that has already started between AGL and SOAFEE. And similarly, there's been also, like from day one, essentially, there's been exchange with the guys from the Venerable AUTOSAR community. And so far, let's say that as far as I'm aware, there's not any actual, code or project level work that's happened, but there is, again, a bunch of something like low-hanging fruit or very kind of neat opportunities on the table that I, again, hope that we will be able to pick up going forward. I mean, so, AUTOSAR applications, we're talking about AUTOSAR Adaptive in this case, but AUTOSAR applications generally, putting that together with some form of a SOAFEE baseline base stack, and kind of maybe merging those two worlds, where SOAFEE is looking at container-based orchestration, and on the AUTOSAR side, we have that automotive specific, kind of safety-oriented middleware and foundational services picture. And there is probably a useful, set of things that could be done together here. And there's an instance of somebody who's already picked some of that up, and begins working in that area. And we're going to see tomorrow colleagues from Electrobit showing how to connect workloads, SOAFEE workloads, containerized workloads with AUTOSAR workloads using a SUMIP implementation. Then taking a quick step, kind of, outside of SOAFEE. This is not directly involving SOAFEE, but it's still relevant, and it's still happening in that same kind of solar system. And it will have, links back and forth, because as you've seen so far, nobody here is working in isolation, and anything that kind of creates benefit somewhere will likely reflect and extend to the other groups as well. And so we do have two examples here of collaborations that do not yet involve SOAFEE. Another very long-standing one, let's say, especially from a project point of view, long before Eclipse SDV, the working group happened, is between Eclipse and Covisa. So Covisa have a run right now, rightfully earned one, around their vehicle signal specification standard. And for a long time, one of the reference implementations using that standard, and also the W3C Vehicle Information Service standard, has been the Eclipse CUXA project, which has been becoming a part of SDV by now. So we do have around that specific data point definition, we do have a very, very long-standing collaboration, and also the developers, maintainers are active in both communities, and there's kind of shared exchange. And this has led to Covisa VSS, well, not ubiquitously yet, but almost everywhere becoming a foundational kind of input for the Eclipse SDV software stack. So in most places in that stack that concern themselves with vehicle abstraction and making vehicle data available to applications, part of the service fabric, there's VSS in there. And there's a very neat thing, to kind of expose you to both of these worlds that's been also made public and come out of the woodwork this year from colleagues in our Bosch organization. That's the Digital Auto project or platform, which is a web-based prototyping, ideation, visualization, testing platform where you can essentially create vehicle applications using VSS data points, and have dashboard simulation kind of things to see what you're doing there, what's happening. And then there's a link to the Eclipse SDV stack to kind of move to the next stage of developing, productizing your application. So that's nice. Have a look. And again, we are looking in that space. I think it's going to be very valid and relevant as soon as possible. To make this stack part of a SOAFEE blueprint. So I hope that can be something that we can report on next time. And then to wrap up this section, you've seen the news, I guess, a couple of weeks ago. The AUTOSAR guys and the Covisa guys went a bit formal and made a decent press release, a real one, because there's been a well, formal decision, formal announcement, these two organizations are now starting work together, collaboration around VSS and creating, vehicle data semantics, vehicle data abstraction in the context of the AUTOSAR adaptive stack, which is, again, highly relevant. I believe that's one of the major things that we need to scale software. And if it happens in that AUTOSAR space, all the better. And in general, the AUTOSAR guys, have to give them kudos because they've been putting a lot of work and effort into discussions and into a working group this year, where they were looking at how and if and where they can open up their IP to become, consumable by open source projects for implementing things that connect to that or use parts of that IP. So I'm not quite sure whether the outcomes are final at this point. Let's just say that there is, as I said, there's work happening there. And as soon as this kind of comes to some fruition, there's going to be a lot of things that both, Eclipse SDV or Covisa or SOAFEE or whoever will be able to do with AUTOSAR. And I really look forward to that, because that will, again, I think reduce a lot of the kind of question marks and the kind of white spaces on the map, because then we can have a joint and useful narrative. All right, let's see. That is my update, actually. That was the gossip section. So I guess summing this up, we had, I don't know, you guys have hopefully kind of seen that we did have a successful moonshot today, this morning, because NASA finally managed to launch the Artemis rocket successfully. Very, very neat, right? Worked like a charm, almost. Just a couple of minutes of delay. So essentially, there's been, I think the space theme is working out well right now. SOAFEE has arrived in the neighborhood in that kind of system. We can say, welcome, SOAFEE. SOAFEE has established links and first useful narratives to neighbors. And that goes, both ways in almost every case. And yeah, I think we are beginning to reduce the uncertainties and the question marks around what, why are we here, and what is with all the others, and kind of, did we need yet another organization kind of in that space? I believe that this year kind of was well spent in getting clarity and getting useful joint narratives out there. All right, so that was my section. Thank you, Robert. Thanks everybody for being here.
Okay, thank you, Daniel. I think you can see that we've moved on a little bit from it being a neighborhood to now a universe. Hence, we have planets and moons and connections. And I think the other key thing is, we have to recognize we're not center of the universe. We're not the sun. We're just another planet, as SOAFEE. And so how do we, communicate with, how do we work with the other planets in our solar system, in our universe? Okay, so we're into the last section before Q&A. I can see you're actually submitting some good questions now. So we'll have hopefully quite a lively Q&A section at the end. In fact, one of the questions is how do we get involved? So I'm going to try and sort of show you how you can get involved as with contributing or consuming SOAFEE. So if you're new to SOAFEE and this has been your first exposure, what I would say is go to the SOAFEE website, and there's quite a lot of documentation in there. The charter for SOAFEE's there. There's different blogs, videos. We'll be posting all this content there as well. So it's a good place to get started to try and understand more detail about what we're trying to do with SOAFEE. There is a SOAFEE Slack channel, which has been mentioned a few times today, which you are welcome to join. That link should work for you to be able to get involved. And you can kind of come in and see what's going on in the different working groups, the different committees, and just generally kind of the chatter that goes on in the SOAFEE world. You can download the SOAFEE reference implementation and bring it onto your system. One of the kind of key things with SOAFEE is it's supposed to be kind of pretty independent, both from a SOAFEE perspective, but also from the workload perspective as to kind of what hardware it will run on. We now have a SOAFEE LinkedIn profile, so please go to LinkedIn and find SOAFEE and follow us. And that's a good way to get updates from SOAFEE as we bring new members on, as we bring in new workshops, as we launch, different parts of the SOAFEE roadmap. They'll all come from our LinkedIn feed as well as our SOAFEE.io website. And you can see on the right-hand side, that's the SOAFEE LinkedIn page. It's only actually been up for about 2 or 3 weeks now, but it's already getting some good traction and actually some good activity and good chatter on the LinkedIn. The last thing is, how do you join the SOAFEE SIG? So there are a couple of ways of doing this. This is actually one of the Q&A that came in. So you can join as a contributing member. So you don't need to sign any agreements, and you can just kind of get involved, come into the Slack channel, see what's going on. And this is really kind of looking for sort of individual contributors. If you want your company to be more involved, then you can become a voting member, which will give you voting rights in the different working groups. But it also it kind of enables you as a corporation to get more involved. You'll get announced on the SOAFEE website. You'll be listed as a member, and that does require a membership agreement. The membership agreement is relatively straightforward. Everybody signs the same agreement. And to answer one of the other questions is, what does it cost? And currently, it is free to join the SOAFEE SIG. So all you have to do is basically sign the membership agreement, and you're in. And you can start getting actively involved. So if you have any questions, just ping me. My email address is there, and I can kind of give you more information of what's involved. I can send you the membership agreement, and generally kind of like talk you through, what's going on. I hope that you will have seen, what all the work groups are kind of getting involved with, what their mission is, what their execution is. So that you can then say, well, oh yeah, that's where I can bring my expertise, or that's where I can, contribute to SOAFEE, as well as, looking at how you could potentially consume SOAFEE and work with SOAFEE as well. So as I say, a lot of that stuff's actually on the website, but if you have any questions, feel free to ping me on my email that's there. So this is the end of the day one content. As I say, we're going to go into Q&A, and we've actually got a bit of extra time for Q&A, which is good because we've got lots of questions come in. But I want to actually point you to tomorrow's agenda. So tomorrow, we're basically having a number of our SOAFEE member companies talk about what they're doing with their technology, their expertise, and with SOAFEE. And we got some really, really interesting papers. It's been quite exciting to try and make each of them 15 minutes. And I hope that we don't overrun like we didn't overrun today. But you can see there's some kind of really cool topics. We've got an AutoSAR topic. We've got the, bringing the AD kit blueprint over to a new software platform. We've got some stuff around, the autonomous driving. We've got simulation, we've got virtual platforms. All of that stuff's going to be discussed tomorrow in these topics. So I really hope you spend the time. I know it's a lot to ask, but yeah, please come along and listen to these really interesting kind of like quick tech talks, if you like. So with that, we are going to go into Q&A. And so, Gina, I'm going to hand over to you. If the panelists would like to all put your videos on, you can stay muted until you answer a question. And then Gina's going to put the questions out and the panelists can answer them as appropriate.
Great, thank you, Robert. So I wanted to address some of the logistics questions first, as I know there's several of you who are looking to get access to this content after the event or share with colleagues. So the meeting recording and slides we will make available on SOAFEE, the SOAFEE website. So we'll send a link to all those who have registered for the symposium when we have those live. In addition, we are creating a YouTube playlist of all of the content So you can see the sections that are interesting to you. This includes the SOAFEE partner content that's happening tomorrow. In addition, we have a number of additional talks that we are providing as a part of the program beyond the list that Robert showed today. So I think we have about 20 talks from partners that we will be posting as a part of this. So a great set of topics and partners who are participating, and we'll again send that YouTube playlist link out to everyone so you can enjoy that at your leisure. So I can start going through the questions. We've answered some of them with text, and so if you asked a question and had yours answered, or take a look to see if it's been answered there, we will try to address some of those in addition so we can have those for the recording. But I'll go through a few of the ones that we haven't addressed yet on text. So let's start with this first one, or one of the ones in here. Is there a plan to make eWall on a virtual platform or virtual hardware so that potential blueprints could make use of it? Is there anyone who wants to take that question from the panel?
Yes, I can take that question. So absolutely, the whole point of the virtual hardware is that it enables a shift left capability where we can test and validate on hardware before the specifics of the silicon are available. We already have the ability to deploy eWall to AWS as an AMI image, and also the ability to deploy to Azure instances as well that are running the ARch64 implementations. So yeah, absolutely. Virtual hardware and cloud-based hardware are absolutely targets for eWall.
Great, thanks, Matt. I have another eWall question here. Does the eWall testing extend to performance testing? Are benchmarks considered, or is the focus on using the blueprints for this?
So in Anmar's absence, I can take that one as well, if you like. This is a question that came up in one of the working group meetings. Currently, the testing is functional. We're not doing performance regression testing at this point in time. It is something that we want to look at implementing. But first and foremost, we want eWall to be a functional platform, because eWall is not designed to be your go-to-market solution. Performance testing isn't as important as functional testing at this point in time. But yes, it is something that we're looking at.
Matt, I think it's fair to say that, you know, eWall could also give us an opportunity to do some of the performance testing on the sort of stack part of it, like what is the impact of a container have on performance, et cetera, et cetera. So I think there might be opportunities, and Paul, I saw you actually submitted the question, and that's one of the things I think we can talk about in the relationship with the AVCC as well.
Great, thank you. So the next question, are you planning to include minimum viable code based as templates for blueprints?
I'll take that one. Can you hear me okay?
Yep.
Yeah, I think that's a great question. And maybe that's an area that I didn't cover in too much detail in the presentation, but we will, we do have a process in place for submitting blueprints by partners. So there is a template and a process that you can find on our shared drive. Please reach out to us on the Slack channel if there's interest. Obviously, the blueprint that's proposed is really entirely up to the partner as far as the functionality of it. Obviously, there's going to be a minimum viable product that the partner would, I would suggest, put down as the requirements for their blueprint initially, and then you can build over time on that functionality for the blueprint. But no, we aren't specific or prescriptive on the functionality of the blueprint, and it's really entirely up to the partner that submits it.
I think, Daniel, to add on that, one of the examples that we gave with the OpenAD kit is these blueprints are not just a sort of one and done. Will actually be, the blueprints can follow the additional functionality that the SOAFEE implementation will have, as well as actually having, extra functionality put into the blueprint. So the move from a monolithic container to 4 separate containers and then 4 microservices is kind of a good example of what we're doing with the OpenAD kit blueprint.
Yeah, that's a great point. It's really a testament to kind of like the SOAFEE architecture as well, right? So we have one example where the Red Hat team was testing the OpenAD kit blueprint as well on their AutoSD reference implementation as well, right? So once we have finalized that testing, we'll share that externally so people can see the value in the blueprint, right? And validating the architecture across multiple reference implementations or reference and partner implementations.
Okay, great. So I'm going to go to a couple of questions from Andy from Amazon. So Andy is interested in submitting one of their use cases and interested in the feedback process after submission for blueprint acceptance and how the loopback process works.
Yeah, so reach out to us on the Slack channel, or maybe I can put a link on the chat as well. On the actual process for submitting, we'll get you the details on the submission process. But the feedback, so it's early days, right? And the process essentially gets submitted through the marketing steering committee. So the blueprint is submitted to the MSC. And then we'll work through getting that socialized as part of the Project Eagle Tiger team. And then really at that point, it's really up to who wants to be on whoever submits it, on who actually takes it and tests it. So I think it's going to be very community-based driven, and the Slack channel for the Project Eagle will probably be the initial feedback loop for your blueprint.
Okay, great. So one additional question from Andy asking, will Blueprint only cover one platform, NXP, for example, or can we have high level across multiple platforms?
That's a great question. So in the template that we provide, we ask you to specify the platform that you plan to validate your blueprint on, and it could be multiple platforms, right? So it's really entirely up to the submitter of the blueprint on how extensive or broad their testing will be for the number of platforms.
But there's actually an extension to that, Daniel, is the owner of the blueprint will be validating on certain hardware platforms, but the idea is those blueprints go out to the external world. So, for example, if another platform provider said, "Oh, I want to try this particular blueprint on my platform," then that's what they're designed for. So I think what we'll see as these blueprints kind of go out into the external world, that there will be more and more support across different hardware platforms and also different software platforms, like what Red Hat are doing with the OpenAD kit.
Great. Okay, so another question. If I understand right, maintaining each microservice in a container is an intensive workload within one domain, as one domain may host multiple services within itself. So is it a challenge for us to figure out an optimal mechanism?
I can take that one. So if I understand the question properly, it's about the resource overhead of running containers. When we look at the traditional container ecosystem, containers tend to be something that's run on top of Linux, and that's the kind of almost the naive way of running a container world. what we're trying to explore through SOAFEE is to understand what the bare minimum infrastructure we need to run something that can be OCI compliant as a container. And that could involve running something on an RTOS, or even going as far as using a microkernel to give me the separation technologies that we need for a container environment, and not have Linux in the loop at all. So my belief that, you know, we look at containers today, yes, they are resource intensive. They're designed for the infrastructure space, but through SOAFEE, we want to understand how we can resolve those issues, make them much lighter weight, but still benefit from the tooling and best practices, the DevOps workflows, the cloud-based infrastructure that tests and validates our workloads, so that we can still use a system-based orchestrator in vehicle to manage the deployment complexity of the software-defined vehicle. If we just take one workload in isolation, it's very easy to deploy that, but we have a complex system architecture with a complex software requirement. We need an intelligent agent to help manage that complexity angle, and the orchestrator becomes that thing.
Great, thank you, Matt. So next question, and some of these have been answered on the chat, but
I think Conrad wanted to say something. Be unmuted.
Okay.
Conrad, do you want to add?
I may add, so it also depends on if you want to have a safety critical container or just a non-safety critical quality managed container. So maybe for the ones that are not quality managed, you can run them on one system. You don't need so heavy isolation, but it really, I think the solution comes down to the question, what do you do with the safety critical containers? What do you do with the freedom of interference? And here we are evaluating the concept Matt just was explaining. On the other side, we are also looking if we can do it with within the Linux system and compare those type of concepts if it would work out. But this, I think, is an ongoing race. It's not, I think we really need to compare the KPIs about overhead, startup times, capabilities of communication between partitions. So there are several technical questions open, which at the end will distinguish the best solution.
Great, thank you, Conrad. So next question, what's the plan of enabling containerization for safety-related applications so that the safety-related autonomous driving applications can also realize CI/CD? So we've gotten answers from both Conrad and Matt here in the chat, but either one of you want to cover that verbally?
Well, I think it's pretty much the same answer to the previous question. If we start to think about containers not just being Linux-based, but being RTOS or microkernel based as well, if we remove Linux from the equation, if we minimize a container to pretty much a bare metal OS or microkernel running in your system, then the things that you need to certify and validate become a lot lighter as well, in terms of the physical number of lines of code that you have in place. So it's our belief that, you know, take a microkernel with a workload on top, that's orders of magnitude easier to get through an ASIL process than if you were to have a standard Linux-based container environment. So it's all about the tooling that we put in place around an OCI-based standard that enables this to happen. And Conrad, do you want to give your feeling as well?
Yeah, totally fits what I have in mind.
Okay, great. Next one, why are we not dealing out VM orchestration? Is it implicitly understood?
Matt,
did you want to take that?
Yeah, my answer to that question is that VM orchestration is an implementation detail, because it's not actually required at an architectural level for what we're doing. When we think about how we separate workloads in terms of spatial and temporal separation, the hypervisor is a tool that can help us with that. But there are other ways of having that same effect in the end system. So as we work through the requirements, as we work towards the architectural vision document, if it becomes necessary to standardize on the relation between the orchestrator and a VMM, then that's the process that we will go through. We will understand what that process looks like. But at this point in time, we're not making any assumption that any particular implementation is required for the SOAFEE architecture.
Okay, great. Thank you, Matt. The next one, we may have addressed this during the how can I get involved, but I want to be sure there's no other comments. As an individual, are there ways for me to contribute to this initiative? I already joined the TSC Google group.
I think Robert covered that a little bit earlier.
Yeah, I mean, coming in as just a contributing member is fine. And the nice thing is, because SOAFEE's being run very openly, you can kind of come in and get involved. What I would say is it's probably good to come in and sort of announce who you are and what you bring to SOAFEE. I think that's actually a really strong thing for you as an individual contributor to come in and do. So I would say, Kenneth, if you're already in the TSC, step up, talk to Matt, talk to some of the working group folks as to what you can bring into SOAFEE.
Okay, great. Next question. Do you plan to release applications or microservices development guidelines for the SOAFEE platform? Is there a plan to provide an application framework? I don't believe we can copy cloud philosophy to the car. There's some sort of contract to deploy applications to the car, and it goes on a little bit more detail, but any answers to that? I think, Matt, you addressed it on the chat.
Yeah, so my answer to that question is that SOAFEE is focusing on a specific problem in the domain, right? So we're looking at OCI standards and how we make them relevant to the automotive domain. If you want to look at the richer OS that will be running on top of SOAFEE, then you need to look at AutoSAR, you need to look to CoVisa to understand what that looks like. SOAFEE is just looking at what we need to do in the cloud native world to make cloud native deployment relevant in safety and real-time domains. Above that sits the other consortia that we talked about earlier in today's presentations.
Okay, great, thank you. Let's see, look. There's one question about the K3S benchmark results. Is that in the slides today or in a different presentation? I just want to make sure that we answer this correctly.
So this was part of the presentations we done in the Mixed Critical Orchestration Work Group by Electrobit. And so one possibility here is to reach out to Electrobit directly to Holger Dormann and to get in contact or contact me in Slack, I will forward it. And of course, we have meeting recordings of the meetings, and the slides are also in our SOAFEE folder. So if you have access to the SOAFEE organization, then you directly get the information.
Great, thank you. Okay, we have a question here, and this may have been addressed during the presentation, but we'll see. So how do we see existing standards such as adaptive AutoSAR coexisting, which already has significant ground covered towards service-oriented architecture? Are there discussions or work being done to explore EWAL and AutoSAR? How can we actively engage?
So I can take that one again if you like, unless someone else wants to take it.
Well, Daniel answered it online, Daniel Krippner. So Daniel.
I have to try to remember what I wrote. Yes, I mean, there's a range of things that I hope can happen there, and I mentioned one of them earlier when I spoke. So I mean, one of the topic areas where I think there's like low-hanging fruit to be had between something like an AUTOSAR adaptive stack and what SOAFEE is doing, and what a couple of others are doing is the topic of workload orchestration. So, you know, like kind of having some way, some form of getting a desired state into your car, into your system, and then have all the different technology areas, tech stacks, kind of, you know, do whatever they need to do to get to that state. And AUTOSAR Adaptive, for example, does define a software management component and API. What's always been, well, complex, let's say, especially looking at this from an open source community point of view, is working with and using those APIs and those data formats that come from adaptive, because they don't have, you know, that's not in their IP licensing. And so that's why I said that it is going to be, in my opinion, it's going to be highly relevant and urgent that they progress the work that they're doing in making their things consumable and usable, because then I believe there's going to be a whole lot of things, you know, that are not very hard to do, but that will give us a lot of benefit, you know, for things like joint common orchestration. Getting into this, like contributing or pushing this forward, I think is it depends where you're coming from, like where you're standing. I mean, best case, I believe, is where somebody does have a strong leg in the AUTOSAR community, probably also like products code, whatever, and can in there push and kind of keep up the momentum for making useful things available and open. And then at the same time, maybe put another leg into something like SOAFEE or Eclipse STV, or, you know, whatever makes sense, Covisa, for example, and build those bridges. And again, mostly not on like PowerPoint, but on actual project and code level. If we find a couple of parties who can do that, then I believe we will have very interesting gossip next year about, you know, linking up these worlds.
So one hint on top of that. So tomorrow we will have a talk by Electrobit about how to do some IP to talk to AUTOSAR out of containers. So this is maybe one of the first links that are then available and explained in that talk.
Yeah, exactly. That will be a good one. Yes.
And actually, my thinking on this is that, you know, what we're doing with SOAFEE is non-competitive with what's happening in the AUTOSAR world, in that we want to express the SOAFEE architecture upstream within OCI and CNCF standards. If we succeed in our vision of making containers real-time and safety capable, then it's up to, we would like to see AUTOSAR adopt the open working that we are doing as a part of their implementation. So we don't need AUTOSAR to be members. We would obviously love AUTOSAR to be members of SOAFEE and to work collaboratively with us in that non-differentiating space. But we are very focused in the part of the problem space that we're trying to solve with SOAFEE. We're not trying to be a full stack solution. If you look at our architecture, there's no mention of an OTA framework, because we're not trying to compete with eSync and other technologies that try to do that. We're trying to be the platform that enables the business logic of those consortia to deliver easily to any platform that is adopting the safe and real-time capable OCI frameworks that are being delivered upstream by SOAFEE.
Great, thank you all. Probably just time for a couple more questions. I'll start with this one. Some popular messaging framework used in robotics, like ROS used by AutoWare 2, do not really support cloud native practices. Do you see a need for cloud native messaging frameworks, or should the existing robotics frameworks level up their game? More generally, how do we send messages from one node to another node under SOAFEE concept? Conrad?
Yes, so in general, I think if we looked into the 12 factors for microservices, I think this is with ROS 2, for example, is very well enabled. So you can build your independent microservices, communicate. So I don't fully agree to the statement, but I think the challenge is rather on a different point here. So on the one side, we want to have containers with microservices in it, and then start communicating maybe even across partitions or even across different ECUs in the car, so in a server zone architecture. And especially here for the safety parts, it will be important to have deterministic latency. We need to know which message takes which time, and if we keep the requirements. And here, I think still for the messaging framework that is underlying, it still needs to fill those requirements. And there are several commercial solutions available that are in that area, but I think for SOAFEE we haven't picked one of it as a particular reference solution. So this is really, it comes to the combination of containers and communication middleware to get this solved. So it's place still for ROS2 if there is something that solves these issues.
So when I think about this problem space as well, it's a part of the deployment complexity angle. So if you think about container to container communication, that's already covered in OCI. We've got CNI, which gives us the ability to configure overlay networking under the orchestrator control. So the question for SOAFEE is, do we need to augment CNI so that it is TSN, so real-time networking aware? Do we need to augment CNI so that it can do point-to-point communication through a non-IP based backbone? So if we have like shared memory with mailbox capabilities and doorbell capabilities, right? We have many mechanisms of communicating from one container to another and one domain to another, and it's going to depend on the underlying fabric of the system that you're deployed to. So in one sense, right, the naive approach is just to say it's TCP all the way. We're going to use IP communication, and ROS2 has that capability now. DDS that they use for their point-to-point communication is capable of delivering over an IP network. The question would be is, does ROS and the DDS community want to be able to communicate over shared memory? And I believe there are zero copy implementations that support that already today. From a SOAFEE perspective, the question is which containers needs to be talking to each other and what the security implications and firewalling implications of that, so that we can ensure that only the containers that are supposed to talk to each other can, and the other containers cannot snoop on any information that's going on between those points. So absolutely, it's not about upping the game in any community, because like DDS is just an implementation of a pub/sub framework that has multiple capabilities of implementation. And actually, if you look at the blueprints that we're working on with OpenAD-Kit, they're using ROS2 and DDS already. So we have a working prototype of container to container ROS2 communication.
Great, thank you all. So we just have 1 minute left, and I know people have hard stops. So we're probably at time. So Robert, any closing remarks that we want to make?
Yeah, I want to say thank you to the panelists, obviously, for their presentations and their Q&A. I also want to say thank you for the attendees and showing real good interest and real good questions that were asked about what we're doing with SOAFEE. Closing remark is come back tomorrow at the same time, and you'll hear more about how things are being implemented, what other technologies, what our members are up to, and some really interesting presentations tomorrow. So thank you again to everyone that attended.
Thank you.
Thank you, guys. Goodbye.
Bye.